Part of the graph of x cubed plus 8y equals 64 is shown below. A tangent is drawn to the curve at the point T, 7, so it's a tangent here, and intersects the curve again at P. Okay, we can see that. Determine the equation of the tangent to the curve at the point T, and we actually have its coordinates. So, we have got a point and we need a gradient. So if we differentiate x cubed, we've got 3x squared plus 8 dy dx is equal to 0. And substitute in x equals 2. So 2 squared is 4 times 3 is 12. 12 plus 8 dy dx is equal to 0. So 8 dy dx is equal to negative 12. Dy dx is equal to negative 3 on 2. So we can use y minus y1 equals mx minus x1. And so y take away 7 is equal to negative 3 over 2, x take away 2, giving me 2y take away 14. So I'm just bringing that 2 up there and multiplying out, is equal to negative 3x plus 6. So we can write that as 3x plus 2y equals 20. Or equivalent. Determine the area of the shaded region. So if we look at that, we want to find the coordinates of P, don't we? And what we can then do is do this trapezium, take away the area under the curve. So we've got 3x plus 2y equals 20. And we've got x cubed plus 8y is equal to 64. And we want where they intersect. So we can use the calculator to do that. I typed it in actually while I was paused. So the CAS gives us that, so we've got negative 4 and y equals 16. So negative 4, 16, and the point we already knew, 2, 7. So it's good that we got that point. Okay, so negative 4, 16. So I know this height is 16. And negative 4 going across to 2, we know that this is 6. And we know the height of that one is 7. So the area that we want is going to be the trapezium. So that's going to be the sum of the parallel sides, which is 16 add 7, multiplied by the distance between them, which is the 6, divided by 2, and then we've got to take away the integral of our curve. Let's just rearrange this. So 8y is equal to 64 take x cubed. So y is going to be 64 minus x cubed over 8. So we'll have the integral of 64 minus x cubed over 8 dx, and that's got to be from negative 4 to 2. And of course we can do all of that on the calculator. And again, I did it while it was paused, and the trapezium is 69, take away 55.5, so we've got 69, take away 55.5, which is 13.5 square units. The shaded region is then rotated about the x-axis. Calculate the volume of the resulted solid, correct to 0.01 cubic units. So the volume is going to be pi times the integral, it's going around the x-axis, so it will be y squared dx, and that would be for the line take away pi times the integral of y squared dx for the curve. So in other words, we're rotating this whole thing around, and then we're going to cut off the bit that you get from rotating that around. So our line was 3x plus 2y is 20. So that would give me 2y is 20 minus 3x, y is 20 minus 3x over 2. So we are going to get pi times the integral from, it was negative 4 to 2, of 20 minus 3x over 2 all squared. And then we're going to have pi times the integral of y squared, which is the 64 minus x cubed over 8 squared dx. And again, all of this can be done on the calculator, which I've just done. I've done the integrals like this, so that's going to be 834 pi, take away 540.857 times pi, and so we can just calculate that. So it's going to be that times pi, take away that times pi, and that gives us 920.94, and that would be cubic units.